Each unit in Math 048 is organized into a video. You watch some exercises that you do and answers to those exercises. From time to time, there will be some additional work you need to submit, as well as there are Moodle quizzes you must complete. So let me show you the overview here. There'll be a summary of the video, and after watching the video later at home, you can watch the summary of the video. Read the summary of the video, I should say. There are then some student learning that you should read, so you have a focus. There's overview of the content that, again, uh, is important, and you need to read this. This is basically the textbook portion of your course content review. Sorry about that. Key terms. There's a summary sheet of the video that I'm going to give you a copy of. When you watch the first video, you should take notes on your video. There's unit activity in each unit, which we are not going to do because we do not have enough students in our class. There are then some exercises. I will do the exercises as examples of what you need to do, and after you have watched me demonstrate how to do the exercises, you will do some review questions. Now, answers to the review questions are also posted within each unit in Moodle, and so you can check all of your answers. Well, exercise 1. The video mentioned the fact that soldiers are bulking up, along with the rest of America. Even so, soldiers are expected to be physically fit. So the question is, suggest some quantitative variables that you might use to measure fitness. So quantitative means some numbers that are measurable. So what I'm going to do here, exercise 1 is the first one. And down here, create some space. So I'm going to put a 1. And I'm just going to jot down some of what I think would be answers. You might have different things that might come to mind. Me, a pulse rate would be something that would be a variable that could be used to determine fitness. Maybe weight. Okay, so weight, but some people can be very fit and have a high weight. So maybe weight isn't the best thing. But something else is called body mass index. Well, body mass index, the BMI, takes into account your height and your weight, and it's really a ratio of your height and weight. So the body mass index could be something that you use to measure fitness. How about blood pressure? That kind of thing. Now, question number 2. This is where we're going to learn how to make stem leaf plots. Below are the number of home runs that Babe Ruth hit in each of the 15 years for the New York Yankees from 1920 to 1934. So in baseball, I'm not a follower of baseball, but the general idea is a home run is where the batter hits the ball hard enough so the batter can run in a circle around all the places. There's first base, second base, third base, and then home plate. And if you can do that loop, first, second, third, and home, without somebody catching the ball and touching them, called a home run. Babe Ruth was really good at this. So anyhow, there's a list of the home runs that he hit over those years, those 14 years, 15 years, in fact. And then you got some questions. Make a stem plot of the home run data. Then use your stem plot to answer questions B and C. Well, what I want to do is, first of all, I want to show you an online tool that you can use to make stem plots. Now, you have to have a way of capturing the data. And I'm going to explain to you how you can move the data from the PDF, which is uploaded into your Moodle site, into the Moodle course, into a format that can be easily grab and put into Google. So here's what we're going to do. This is the PDF of Unit 2 as viewed in Chrome. What I want you to do is you have the option of downloading this PDF to your device. You need to do that. So download the PDF to your device and make sure you put it in a file folder that you can access, that you can find easily. Maybe just put it on your desktop. Next, what I want you to do is find some version of Microsoft Word. I'm using Word 2016. You might have an older version of Word. What you need to do is open up your Word program. Once you have Word started up, choose a blank document. And now what you want to do is you want to open up that PDF into your document. So here's how you're going to do that. File, open. I've downloaded this on my PC and I've put it into a file folder in Math 048. And I'm going to upload that now. There it is, PDF against all odds. And it says, well, it's going to convert it to a Word editable document. What's going to happen is something can move around a little bit. It's not going to look quite as pretty, but I'll show you how you can deal with that. Here we go. I'm going to do the upload. Bonk. There it is. Okay. So now you've taken the PDF document out, the Word document. Here's the thing. Some of the numbers don't come across nicely in tables. That's okay. It's just a pile of numbers, and we can grab those. So I'm going to scroll down to the exercise. Well, there's Babe Ruth's averages right there. What I'm going to do is I'm going to copy those, and I'm going to put them into the stem leaf calculator that's located just lower down in your Moodle course. You need to find the stem leaf calculator. Why don't you pause the video and do that now? What I'm going to do now is I'm going to take the data in exercise 2, which is in a Word document. It must be in a Word document. This data must be in a Word document so you can pull it out. In a PDF, you cannot remove numbers. It's a photograph, basically. But in a Word document, all the stuff is editable. So I'm going to select the numbers in question 2. With the mouse, I can right click and select copy. Then what I'm going to do is I'm going to find the tab that has the stem plot app that you would have downloaded from the Moodle course in Unit 2 from BMath 048. And in the data set, to plot your data, in the single data set selection, I'm going to right click, and then I'm going to left click my mouse, and I'm going to go paste. There are the numbers. Now I select generate stem plot, and there's the stem plot. So the way to read the stem plot is the stem are in tens and the leaves are in ones. So that means that in this stem plot, the top 2 entries, one year there were 22 runs, another year there were 25 runs. When the stems are 3, That's the tens place value. And the leaf is a 4, 3 in the tens, and 4 in the ones becomes 34. 3 in the tens and 5 in the ones becomes 35. So, question 2a, make a stem plot. Done that. Then use your stem plot to answer questions B and C. Well, describe the shape of the distribution. Is it roughly symmetric or not? Is it unimodal, like a single peak, or is it multimodal, more than one peak? Okay, let's take a look at it. Well, here's the stem plot, Babe Ruth's home run data. And it seems that there's only one peak right here. I don't know, I suppose you can see my pointing device. And it's unimodal because there's only one peak. And I would say it's also symmetrical. So what we've done is we've taken a collection of numbers, these numbers, and sorry about that, and we've taken this collection of numbers and we've transformed them into basically so we can maybe come up with some interpretations. Go back to the question. The distribution is unimodal and symmetrical. That's the answer to question 2b. 2c is, what is the center? This is the number of home runs that Babe Ruth hit in a typical year. Well, what I'm going to do, there are actually 15 years worth of data. So what's the middle of a collection of 15? That would be 7 or 8. Let's see. And if I count in 7, 1, 2, 3, 4, 5, 6, 7, that's a 6. If I count from the other direction, 1, 2, 3, 4, 5, 6, 7, that's a 6. There's a 6 in the middle here in this leaf that has a bunch of numbers. So right there, that middle 6 is the for 46 runs because the stem was a 4 and that's 6 or 7 items. Sorry, 7 items. And 7 items above that middle 6. Kind of looks like to me that would be the most common number of home runs that Babe Ruth. Uh, the center is 46 runs. Now, 2D. Ruth's record of 60 home runs in 1927 stood for more than 30 years. Is 60 an observation that falls outside the pattern of the other observations and hence to be considered outlier? Well, let's put the data again, or the leaf plot. Well, here's 60. How could that be an outlier? Well, in some years, Babe Ruth hit only 22 runs or 25 runs. Some years he hit 34 and 35. 60 is at the edge, really. It's the upper limit of what he hit. In the same way that 22 and 25 runs in those 2 years were the bottom limit of what he would hit. So I would not really consider 60 to be an outlier. If Babe Ruth had hit 90 runs in a year, I'd be like way down here in your stem plot. I'm pretty sure you can see my pointing device moving around there. That would be an outlier, 90 runs, because it's just totally outside of the typical grouping of this family plot. But because of the symmetry of the plot, 60, not really an outlier, but then again, not really most common. Sure. Okay, so 60 is not an outlier. 90 runs in a year. Sure, it would be. All right, our next question involves an SAT distribution. SAT, standardized test for college admission, used mostly in the States. Um, there's a table contains the average score for each state on different fields, for reading, math, writing. Okay, the table's located here. Now, right now, I'm just using my tablet in OneNote application. But in order to capture the data that you need to for this, um, you need to actually once again be in the Word document because that's editable. So I'm going to switch to the Word document, which you need to be in now. Okay, so here's the table. Oh, look at that. It's messed up a little bit, eh? Here's what I'm going to do. I'm going to take my mousey and I'm going to go right after where it says See Table on next page. I'm going to click right behind that and I'm going to push Enter. And that's going to force all the information down onto the next page. Okay. Now I've got District of Columbia in here, and it's made a split. So what I'm going to do, I'm going to edit that, and just to make it easier. Oh, hang on. My mistake. I'm going to edit that in the sense that I'm going to type. There. Okay, so I'm going to go and change this District of Columbia. So that's just all on one line. So I've edited that. I just want it to be a nice clean cut when I do this. Okay, so well, what questions do we have? Make a stem plot of the 51 average SAT critical reading scores. So I look at the top of the table and I find, well, critical reading. Well, there's actually, because there's 51 states, there's 2 columns of critical reading. So I'm going to make my stem plot. And I'm going to have to copy the data in 2 sections. So critical reading. So I'm going to position my mouse in front of the very first number, and then I'm going to drag my mouse down. Then I'm going to click, I'm going to drag my mouse down and click the left button, or the right button, I should say. And after I click the right button, I have the option of copying. So I'm going to copy those numbers. Next, I'm going to go to my stem leaf plotting tool. I'm going to clear what's in there. I'm going to click in the box. I'm going to click my right mouse button. Now, if you don't have a mouse, you can, you've got a laptop. It'll be the right button, the button on the right side beneath your trackpad. So I'm going to click my right mouse button, or my right trackpad, and I'm going to paste those numbers in. There they are. And see where the cursor is? It's flashing down at the bottom. I'm going to go back and get some more data now. So here we go. Going back to the Word document. This is the Word one, so I'm going to click there. And I've got to collect the other set of data. And again, this is critical reading. So I'm going to scroll down, let go, click the right button, copy, go find the stem leaf plotter. There it is. I'm going to click below the last term. Got a flashing cursor. Click the right mouse button, select paste. Whew, and all that data is in there now. 51 states, and now generate stem plot. Okay, so this is the stem plot of SAT scores, average SAT scores on reading comprehension for each of the 51 states. Now notice the stem is in tens and the leaf is in ones, but the numbers in the stems are numbers like 46. Let me say 46 multiplied. So if you take 46 multiplied by 10, that's 460. Okay, and each leaf for the very first two entries are ones. So there are two states that actually had average scores of 469 on the SAT. Or, um, I believe it was being compared. But on the other end, well, there were a number of states that had scores of 590s. This is 590, 592, 593, 596, 599. And you can see that this is not a unimodal distribution. Um, there might be a peak there. It's not really symmetrical. Anyway, I'm going to go back to the questions and see what we need to figure out. Take a look. So I made the STEM plot for critical reading scores. Based on your STEM plot, describe the overall shape of the distribution of SAT critical reading scores. Approximate the center. Are there any outliers? Well, let's make some more room on here so we can write. Okay. Well, the overall shape of this distribution, it's kind of skewed to the high end. But then there's a grouping down around 480, 490, but there's no real definitive shape to it. What's the center of it? Well, there are 51 states. So that means there's 51 pieces of data. So the center would have 25 below it and 25 above it. Well, what number would that be here? Let me just count that for you. Well, it turns out that right here, 523 is the center. There's 25 pieces of information below this middle three here and 25 above. Now, are there any outliers? Well, there's not really outliers because there's lots of information. It doesn't have any specific shape. If one state had critical reading score of 200, that would be definitely an outlier. But it seems that there is no outlier as such. Now, we're going to make a back-to-back plot of SAT math and writing scores, math and writing. Okay, well, back-to-back plot. See how we do that. Well, here I've got the plot generator. And you notice that you can have a single data set, which is what we've been using, or back data sets. Let's use back. Gotta select that. First thing I need to do is I need to clear the set of data. There. All right. So now what I'm going to do is, because I'm going to be comparing math scores to reading scores, I can just enter the data. So once again, I'm going to show you how I can copy the data in. I could have left the reading scores there, but I'm not sure how to do it. Once again, here we go. So I'm going to find the Word document, and we are doing reading scores and math scores. So I'm going to use a mouse. In the Word document, I'm going to select the first column of the critical reading scores, right, copy, go to my stem leaf plotter, right click, select paste. Cursor's down at the bottom. Great. Now I go back to the Word document, select the next column, critical reading scores. There we go. Right click, as I said, right click, copy, go to stem leaf plotter, go over the cursor, right click, paste. Great. So now I've got all that data in there for critical reading scores, and that's in data set number 1. Now, data set number 2. Come down here, click on that box. Go to the Word document, click. Data set 2 is math. exactly the same thing. Right click, copy, go to dataset 2, right click, paste. There's the cursor down at the bottom. Go back to the data set. And I want to select the next column for math. Here we go. There's the math. Right click, copy, and go to the stem leaf plotter. There's the flashing cursor. I'm going to paste in the data. There it is. So math is in data set 2. Critical reading is in data set 1. Stem plot. Whoa, look at that. Okay. Well, there's the stem plot. I'm going to very interesting. What the stem plot has done is it's taken data and it's condensed it so that it's really hard to tell. It's made the stem in 100s. So this is where you want to do an expanded stem plot to break out the information so you can get better info. So on the left here, this is the math data because there's numbers that are in the 600s. And if you recall, with the critical reading scores, there are no numbers in the 600s. So with the stem leaf plotter, we've got math on the left, reading on the right. Well, to answer question C, make a back-to-back. Okay, we did the back-to-back stem plot using the plotting tool. And in this case, the software decided to make stem in 100s. So we had a very condensed stem plot. Of course, you could do this on paper. Any of the stuff I've just done, you could do on paper, and you could make your own stem leaf plots. Nothing wrong with that. In fact, that's what you're going to have to do for an exercise. Make sure that you know how to do that. Now, that's question number B. Like C, we did. C's done, and it's a condensed stem plot. And really, for D, based on your what we saw, like you can't read it. There's no good info. No good info. The final question before the review questions that you will do is a local television station gathered data on the ages of viewers of Action, a program aimed at young audiences. And there's some ages and years reported by a rating service. You make a stem plot of the age distribution. Now the instructions are the first step, truncate the number by discarding the digit after the decimal point. Then describe the main features of the distribution. Well, here's the thing: the software we're using will do the truncation of the decimal point for you and round the number appropriately. So I'm going to go to the Word document, select these numbers here in the Word document, and make a stem leaf plot out of them. Here we go. So here's the Word document, and here's those numbers. Notice they're kind of messy. Anyhow, I'm going to copy those. I'm going to go to the stem leaf plotter, clear that, click in there, paste in all those ages, and generate a stem plot. All right. Well, here's another example of an outlier. Well, look at this. So you've got into young audiences. You got about 5 and 6-year-olds, 9-year-olds watching this program. 10-year-olds. Look at that. You got 16-year-olds, 17-year-olds, two people in their 20s. You got the 60-year-olds, two people in their 60s, a 60-year-old and a 65-year-old. And you've got the oldest person on the planet. They're 120 years old. Maybe they've been having some cognitive issues in their old age, and so they're in the program. Well, that's the end of the lesson. Now it's your turn to make some stem leaf